So the topic for, for today is about circuit breaker. So what is circuit breaker? Circuit breaker is a switching device that interrupts the abnormal or fault current. It is a mechanical device that disturbs the flow of high magnitude current and additions perform the functions of switch, and then is mainly designed for closing or opening of an electrical circuit, thus protects the electrical system from damage. And its function is to detect a fault condition and by interrupting continuity to immediately discontinue electrical flow. So what is the working principle of circuit breaker? Circuit breaker is essentially consists of fixed and moving contacts. So these contacts are touching each other and carrying the current under the normal conditions when the circuit is closed. During the normal operating condition, the arms of the circuit breaker can be opened or closed for a switching and maintenance of the system. To open the circuit breaker, only a pressure is required to be applied to a trigger. So, circuit breaker ratings. The rating of the circuit breaker is given on the duties that are performed by it. For complete specification, standard ratings in various tests of switches, switch, switches and circuit breakers may be consulted. Apart from the normal working of circuit breakers, the circuit breaker is required to perform following three major duties under short circuit conditions. First, it is capable of breaking the faulty section of the system. This is described as the breaking capacity of the circuit breaker. The circuit breaker must be capable of making the circuit in the greatest asymmetrical current in the current wave. So this refers to making the capacity of the circuit breaker. So third, it must be capable of carrying fault safely for a short time while the other breaker is clearing the fault. This refers to the short time capacity of a circuit breaker. So next, uh, in addition to the above rating, the circuit breaker should be specified in terms of rated voltage, so rated current, rated frequency, and operating duty, breaking contact, and making capacity and short circuit current. So back to the rated voltage. So what is rated voltage? The rated maximum voltage of the circuit breaker is the highest RMS or root mean square voltage above nominal voltage for which the circuit breaker is designed and its the upper limits for operation. The rated voltage is depicted in kilovolt RMS in use phase-to-phase voltage for three-phase circuit. In rated current, the rated normal current of the circuit breaker is the RMS value of the current with which the circuit breaker shall be able to carry a rated frequency and rated voltage continuously under specified conditions. So third is the rated frequency. This is the rated frequency of a circuit breaker. It is the frequency at which it is designed to operate. Standard frequency is 50 Hz. And next is operating duty. The operating duty of the circuit breaker consists of the prescribed number of unit operations at stated intervals. The operating sequence refers the opening and closing operation of circuit breaker contacts. And next is a breaking contact. The terms express the highest number of short circuit current that the breakers are capable of breaking under specified conditions of transient recovery voltage and power frequency voltage. It is expressed in kilo, kiloampere RMS at contact separation. The breaking capacities are divided into two types. First is symmetrical breaking capacity of a circuit breaker and asymmetrical breaking capacity of a circuit breaker. So next is making capacity. There is always the possibility that a circuit breaker is closed under short circuit conditions. The making capacity of the circuit breaker is its ability to withstand under the effect of electromagnetic forces, which are directly proportional to the square of the peak value of the making current of the circuit breaker. And next is short circuit current. The short circuit current of a circuit breaker is the RMS value of, of current that a breaker can carry in a fully closed conditions without damage for a specified time interval under prescribed conditions. It is normally expressed regarding terms of kiloampere for 1 second or 4 seconds. This rating are based on the thermal limitations. So what we're gonna do to test the circuit breaker if it is okay or not okay, or it is a good condition or bad condition. So we have some tests that we use to test our circuit breaker. So first is mechanical test. It is mechanical ability type testing involving the repeated opening and closing of the breaker. A circuit breaker must open and close at the correct speed and perform its designated duty and operation without mechanical failure. So next is thermal test. Thermal tests are carried out to check the thermal behavior of the circuit breakers. So the breaker under test deal with a steady state temperature rises due to the flow of rated current through its pole and rated condition. The temperature rise for rated current should not exceed 40 degrees, or for current less than 800 ampere normal current, and 50 degree for normal value of current 800 ampere and above. So next is a dielectric test. These tests are performed to check power frequency and pulse voltage with shunt capacity. Power frequency tests are kept on a new circuit breaker. The test voltage changes with a circuit breaker rated voltage. Short circuit test. This is a popular test among all these tests. Circuit breakers are subjected to sudden short circuits. In short circuit test laboratories and oscillograms are taken to know the behavior of the circuit breakers at the time of switching, and during contact breaking, and after the arc extension. So types of circuit breaker. Circuit breakers are mainly classified on the basis of rated voltages. Circuit breakers below rated voltages of 1000 volts are known as the low voltage circuit breakers, and above 1000 volts are called the high voltage circuit breaker. So first is molded case circuit breaker. This circuit breaker is used around is used in the building with a three use of three phase three phase voltage. So MCCB is a kind of circuit breaker which is enclosed in the molding or housing of a molded material, and that is the reason it is known as molded case circuit breaker. It is generally used for the current ratings up to 1600 ampere and port level up to 150 kiloampere. It offers protection against overload and short circuits through bimetal and solenoid. This day, microprocessor-based MCCBs are being very popular due to the quick functioning of their electronic type release. So next is a miniature circuit breaker, or MCB. MCB is a circuit breaker which is used for protection where current ratings are lower. It can be used up to 125 ampere circuits. Unlike MCCBs, it also offers protection against overload and short circuit through bimetal and solenoid. These days, Class 3 MCBs are very popular due to their ability of tripping quickly and also minimum loss of breakthrough energy. So this is the part of, of the MCCB. We have the up upper terminal, or the incoming supply, thermal protection by metal, arc chamber, electromagnetic protection, or either the solenoid or magnetic coil, fixed contact and moving contact, lower terminal or outgoing load, that's DIN rail holder, and this is a tripping lever, operating mechanism, operator, and a space for identification mark. This is the MCCB. So air circuit breaker. I'm not popular about this. So let's let's discuss. Air circuit breaker, or ACB as the name suggests. It's the circuit breaker where the medium of arc reaching is air. ACB is used for the high current application, or we can say that ACB can offer protection against overload and short circuit up to 6,300 ampere. Tripping in ACB is achieved through release. The release is known as the mind of ACB, as it only suggests the ACB to trip in case of fault. And next is a motor protection circuit breaker. So MCB are especially for motor protections, like I said, and MCB as a stand-alone device offers protection against overload, short circuit, and single phasing. Thus is used specifically for motor applications. Display the diagram. This is a three-phase load, and the neutral, then for terminals, NC terminals. So this is the output terminals going to electric motor three-phase, and this is the kind of um, a motor protection circuit breaker. It's like a which have like a rotating mechanism. Next is a residual current circuit breaker. The RCCBs, as the name suggests, offer protection against earth leakage. It is used in homes, offices, and industries according to the current sensitivity required as per application. In case of current leakage, it senses the same encrypts, thus saving the human circuit from shock and adverse effects of current leakage. This, this is the residual current in this physical, in this supply. This is the diagram of this breaker. This supply line, the live and neutral. So we have sensing coil, test both in primary coil and secondary coil. So this is another type of circuit breaker. Medium voltage and high voltage circuit breakers. Voltage level from 1 kilovolt to 69 kilovolt is categorized under medium, and 69 kilovolt to 230 kilovolt is categorized as high voltage circuit breakers. Operating in these voltage ranges are known as a medium and high trade voltage, respectively. So this is the all circuit breaker. All circuit breaker is such type of circuit breaker which use oil as a dielectric or insulating medium for arc extension. Uh, this is the this is this breaker is used oil for the for for, for distinguish the arc, arc extension to may maiwasan yung fire. In all circuit breaker, the contacts of the breaker are made to separate within an insulating oil. When the fault occurs in the system, the contacts of the circuit breaker are open under the insulating oil, and an arc is developed between them, and the heat of the arc is evaporated in the surrounding oil. The oil circuit breaker is divided into two categories, which is bulk oil circuit breaker and a minimum oil circuit breaker. This is the diagram. Conductor, that conductor, that's the bushing. So the fixed contact dielectric oil in the moving contact. This is the arc. This is the arc. This is the